All right, so for this week's seminar, I picked a paper that I think is, well, it's pretty timely for all of us here. It comes out of Carnegie Mellon, and it has some really pressing implications for how we teach and assess our own students. The title is Changes in Coding Behavior and Performance Since the Introduction of LLMs, a 10-semester study.
So what are we really trying to figure out here? We all have our stories. We talk about it in the hallways, what we think we're seeing in our classes. But this paper tries to get past the anecdotes and answer the real question. What does the data actually say? How have these tools really changed the way our students code? And to do that, the authors found a really clever setup. They managed to use 5 years of data from a single programming assignment that never changed. It's what you could call a perfect natural experiment, really. It gives us this clean before and after picture, with the public release of ChatGPT sitting right in the middle. Okay, so here's how we'll walk through it. First, we'll look at the experimental setup itself. Then we'll dive into the pretty dramatic shift in student behavior they found. After that, we'll question whether all that new activity is even effective, unpack this really weird performance paradox in the grades, and finally, we'll try to make sense of it all with this idea of the centaur developer.
All right, first up, the 10-semester question. Basically, how they set this whole thing up. Because, the methodology here is everything. If we don't buy the setup, we can't trust the results.
So the context is a grad-level cloud computing course. And the key, the absolute key to this whole study, is that they had one programming task, an implementation of PageRank that went completely unchanged for 10 straight semesters. 5 before ChatGPT, 5 after. That consistency is what makes this so powerful. It's a rock-solid baseline.
And we're not talking about a small sample size either. The dataset covers over 900 enrollments, and more than 700 students actually attempted the specific task that they analyzed. So yeah, it's a pretty robust dataset to be drawing conclusions from. Now, another crucial point is who we're looking at here. These aren't undergrads fumbling through their first programming course. This cohort is almost entirely made up of graduate students. These are people who, presumably, already know how to code pretty well. Just keep that in the back of your mind, because it makes what comes next, well, a lot more striking.
Okay, so now we get to the shift itself. This is where we start to see some pretty dramatic changes in how students are actually approaching the problem. The differences are not subtle.
First off, just look at the lines of code. It's striking. Before that November 2022 cutoff, a perfect scoring submission was, reliably around 100 lines. But after, the length just explodes. And remember, these are still perfect score submissions. The code is just bigger, more bloated, for the same result.
But it's not just that the final code is longer. The process of getting there completely changed. This graph shows what they call total edit distance. It's basically the total number of lines a student adds, deletes, or changes across all their attempts. And look at that jump. The median amount of change went up by nearly 10 times. It's just a staggering increase.
And you might think, well, maybe they're just submitting more often. But that's not the whole story. The average edit distance per submission nearly tripled. So with every single attempt, students are making huge, sweeping changes. It's not this careful, iterative process anymore. It's more like a rip and replace strategy on every submission.
So the evidence here is pretty clear, right? Students are writing longer code, and they're making these huge, drastic edits to get there. The whole approach to the problem has fundamentally changed, which leads to the obvious next question. Is any of this actually helping? Is it better?
And this is where the story takes a fascinating turn. All this extra activity, all this code churn, is it actually effective? Are they making more progress? Well, as it turns out, not so much.
So the authors came up with this metric, average submission effect. It's a simple idea. On average, how much does your score go up each time you submit? And what they found is, well, it's been dropping like a rock, especially in the last couple of semesters. They're making all these edits, but each attempt is actually accomplishing less and less. This chart here tells the same story, just in a different way. The proportion of submissions that actually lead to a higher score, that's the teal bar, it stayed pretty flat. But look at the yellow bars. Those are submissions that result in the exact same score, no progress. That is more than doubled. It suggests a lot of frantic editing that's, well, going nowhere.
So to sum up this part, students are making way more edits for way less progress. They're just spinning their wheels. And the hypothesis here, the one I think we've all suspected, is that they're getting stuck in this loop of just pasting in code from an LLM and hoping it works, without really understanding what it's doing.
Okay, so if they're being less efficient, you'd think their grades would suffer, right? But it's not that simple. And that brings us to what the paper calls the performance paradox. Things get a bit strange here.
They looked at performance in 3 different ways. First, the score on this one PageRank task. No change. Pretty much everyone gets to 100% eventually. Fine. But second, the overall grade for all individual projects, that actually went down a bit. A small but statistically significant drop. And then, this is the really weird part, the scores on the big final team project, they went up. So what on earth is going on?
These two plots really lay out the paradox. On the left, for individual projects, more code churn is linked to slightly lower grades. That's true both before and after ChatGPT. But look at the chart on the right for team projects. Before ChatGPT, the same was true. More churn meant a lower grade. But after ChatGPT, the teal dots, that connection is just gone. The line goes completely flat. All that frantic editing no longer predicts a worse outcome for the team.
So this leads to the author's main interpretation, and I think it's a powerful one. LLMs might be acting as a crutch. For an individual, this crutch can mask a real lack of understanding, which hurts their overall individual performance. But when you put them in a team, that same crutch becomes a kind of force multiplier. It's like having an extra, tireless, if sometimes clueless, teammate that helps the group push through, boosting the team's output.
So the big question is, what does this all mean for us? For how we teach? The paper wraps up by proposing a really interesting framework for thinking about this, which they call the rise of the centaur developer.
Yeah, the term comes from freestyle chess, where you have these human plus AI teams called centaurs. And it turns out a good human player paired with a good AI can consistently beat any lone human or any lone AI. The human's job shifts, right? It's not about the tactical move-by-move calculations anymore. It's about strategy, about guiding the AI, about knowing which of its suggestions are brilliant and which are nonsense. The argument is that this is exactly the shift we're seeing in software development.
And this really is the core takeaway for us as educators. The paper says it best. Our assessments must evolve to measure what is important for the human part of the centaur. If the most valuable skill is no longer just writing the code line by line, but this higher-level strategic thinking, well then our entire assessment infrastructure is fundamentally missing the point.
So that's the big open question this paper leaves us with. The data seems pretty clear that our old metrics, our old definitions of mastery, are starting to break down. So the question for us, for everyone in this room, is what do we do about it? How do we start to redefine what it even means to be a master programmer in this new age of AI? And with that, I'd love to open it up for discussion.